Hello all. Today I'm going to code or program an on-delay timer using Arduino, and this whole tutorial is all about that. So before proceeding further, let us see what is the prerequisite and who are the expected audiences for this tutorial. The expected audiences are beginners who started learning and using Arduino controller, and prerequisite for this tutorial is knowledge of basic electronics and familiarity with Arduino. So let's get started. Timers such as on-delay timers, off-delay timers, pulse timers, most commonly available as ready-made instructions or instruction blocks in the PLCs. However, they are not available in Arduino IDE software platform. Though many libraries may have developed to use the timers, it is good learning to prepare them using Arduino IDE tool. Here we are going to use basic instructions and functions available in the Arduino IDE and going to implement the on-delay timer. So this whole tutorial is divided into 5 sections. In section 1, we will learn or we will see how on-delay timer works. In section 2, we'll see delay function and its limitation. In section 3, we will see Mealy's function and its working. Mealy's function plays major role in timing related applications or code in the Arduino. So it is quite important to learn this. In section 4, we will learn concept behind the logic using day-to-day example. This will make our work little bit easy. In section 5, we will finally prepare the delay timer on-delay timer using Arduino. Here I would like to recommend is to do not shuffle, change or skip the sections. These sections are prepared in step-by-step way, and changing their sequence or skipping they may cause confusion to you. So let's see how on-delay timer works. On-delay timer delays the on action by specified time. Here we are taking very simple example. We have a switch and then bulb. The switch is input and the bulb is output. So, and there is a timer, on-delay timer in between this input and output. So when switch turn on, this timer gets activates and it starts counting the time. So when it completes the 30 seconds, it turns the bulb on, and when switch turns off, the bulb turns off immediately. So this delay timer in between the input trigger and output action causes the delay in the action by 30 seconds when it receives input trigger. That's why it is called as a on delay timer, but it does not affect the off operation. So when we turn the switch off, this timer get deactivated immediately and it turns the output bulb off. So this timer only delays the on action and does not delay the off action. So that's why it is called as a on delay timer. Let us see the operation of on delay timer using Siemens PLC and TIA portal software. So this is a TIA portal software for the Siemens PLC, and this area is a working area where we prepare ladder diagram or functional block diagram. Here we have used the ladder diagram for demonstrating the on delay timer. So here we have a switch and then we have a bulb, and in between this output and input switch we have inserted an on delay timer. The time period for this timer, time specified for this timer is 10 seconds. Currently this logic is online and it's showing the online status. The dotted blue line means it is off or it is deactivated, and the green line means, solid green line means it is on or it is passing the current. Currently the switch is off, hence the bulb is also off. If we turn this switch on, this timer gets the input and it start counting the time. When it finishes counting the time, it turns the bulb on, and when we turn this switch off, it immediately turns this bulb off. So timer introduces a delay in between on action. It doesn't introduce a delay in between off action. That's why it is called as an on delay timer. Let's see it one more time. Turn on, timer timer gets activated, starts counting time. It counts the time up to 10. Once it reaches to the 10 preset time, it turns the bulb on. So this is the operation of on delay timer. Okay, so let's study delay function in this section. If we search delay function in the website for Arduino, it will give us this information. The description says that delay function pauses the program for the amount of time specified as a parameter. And here is the syntax. So whatever time period we specify in this parenthesis, the delay function will pause the program for that particular time. And once that time period is complete, then the next instruction after the delay will be executed. Now let us see how delay function pauses the program, or what is the source code, or what is the code behind this delay function. Here is the logic. So when we enter the delay instruction with the time specified in it, the processor executes the NOP instruction, and it keeps executing the NOP instruction in the loop until it completes the time period specified into the delay function. And once it completes the time period specified in delay function, it goes to the next instruction. It means ideally it's not doing anything, it's just repeating, it's executing some non-useful instruction, mostly NOP. NOP is the no operation instruction, which only waste time. So assume that execution of NOP instruction takes 1 milliseconds and we specified a delay of 1000 milliseconds. Then this loop will execute 1000 times doing nothing, and then it will jump to the next instruction. So this next instruction, if delay instruction before it, it has to wait until the time period is consumed. So please watch this flow chart, and let's try to understand what exactly happens when delay function is executed by the Arduino. So let's prepare a program for demonstration of this delay function and for more clarity. For the program, we have taken this setup. If we see, two LEDs are connected to the pin number 9 and 8. Green LED is connected to pin number 9 and red LED is connected to the pin number 8. At the same time, two switches are connected to the pin number 3 and 2. Here what we are going to do is, we will blink the red LED by the amount of time specified in delay function, and we'll blink this LED using delay function, and then this green LED will be operated by the switch number 2, or the switch which is connected to the pin number 2. So whenever this switch is on, the green LED will on, and whenever this switch is off, the green LED will be off. This is the required sequence which we are going to prepare in our Arduino. And adjacent video we are showing its actual setup. So in this actual setup we can see two LEDs. These LEDs are connected to the pin number 8 and 9, and two switches, they are connected to the pin number 2 and 3. So let's write a code for it. The code is already ready. Here we have defined variables and assigned pin numbers to them. This is a good practice because if your pin number changes, for example, if someone changes the switch physically to the number 4 or 5, you just need to make the change over here, and wherever you use this variable in the program, that change will be automatically updated over there. So instead of directly using pin numbers, assign variables to them and then using in the program is good practice. After defining the variables, we configured the pins as per their inputs and outputs. We just need to configure these pins once, so we wrote it into the setup. Whatever code written into the setup, it gets executed only once. Here we configure the switch 1 as an input, the red LED as an output, and green LED as an output. And as discussed before, we will blink the red LED and we will turn the switch on and off based upon, sorry, we will turn green LED on and off based upon the switch 1 status. In loop, we write the program which repeats itself. When we write the program in the loop, processor executes the first instruction and then it executes the all other instruction in rows until it reaches to the last instruction, and it goes back again to the first instruction, and same sequence repeats itself indefinitely until the controller is powered on. The first task we are doing is blinking of the red LED. We write delay function here with 1000 as a time period specified in milliseconds. So this is a 1 second delay. When controller executes this instruction, it pauses the program over here. Once 1 second completes, then it executes the next instruction, which is we are writing red LED low, means we are turning the red LED off. Again we are providing a delay of 1 second, and the next instruction we are turning red LED on. So net result of this 4-line code is the blinking of red LED by 1 second. And in task 2 we are turning the green LED on and off based upon the switch 1 status. Initially we read the switch 1 status, and if this switch 1 status is high, we need to use equal sign 2 times when we are checking the condition. So when if this switch 1 is high, then we are turning the green LED on, and when this switch 1 is low, else means when this switch 1 is low, we are turning the green LED off. Compiled. Let's download it now. Okay. You can see now the red LED is blinking, and sorry, and the green LED is following the switch number 1. But here we can see that the green LED is not performing the its task as per the program. Right now, there is some kind of weird operation happening. let's change the let's change the delay to 3 seconds. So blink operation will happen after every 3 seconds. Now we can the program. Now you can see that red LED is blinking after every 3 seconds. And now if I press the switch is not turning on the green LED, or it turns on, but now it's not following the required sequence. We expect it to turn on when the switch is on, and we expect it to turn off when the switch is off, but it does not follow that. This is the drawback of using the delay function in the program. We have seen these two operations, and we have observed that this second task is not getting operated. This is because this delay function is pausing the program over here somewhere when we press the switch one. That's why we cannot use delay functions in the real program, as it delays the actual execution of the program. For example, this program will take 6 seconds, more than 6 seconds to execute from the first instruction to the last instructions due to the delays added in between it. And this is not acceptable. Means we have a 16 megahertz frequency, clock frequency. Time period of every clock is almost 0.06 something microseconds. This processor at Mega 328P or the Arduino takes only few microseconds to execute the instruction. We remove these delay functions from this program. This program will take only few microseconds to execute from this first instruction to the last instruction. But adding these delay functions in between, these are software delay functions, so adding these delay functions in between seriously affecting the scan time or execution time of the program. Hence, these delay functions are, though they are very easy to use, they are mostly not used, or I can say 99% they are not used in real application or real program. That is why we need to find out another solution uh, to perform time related activities.